Wow, you would never think a hurricane could destroy your entire house.
Yeah, your house and everything in it. That'd be just my luck to go to Florida and get stuck in a hurricane.
I just finished entering our notes that we took at Mosey from our problem log. You can download your own problem log from the NASA Wi-Fi's website.
We have a lot of new information. I think we need to go to the problem board.
We know the tropical depression is now a hurricane.
We know that hurricanes generally move from the east to the west.
And we know that water vapor is the primary source of energy that drives a hurricane.
What we need to know is more about the probability that the hurricane will actually hit Florida.
Where should we go?
Let's go talk to Dr. D. I'm sure he can help us out.
Hi, Dr. D. What are you doing?
Working on a tornado box. Your work on hurricanes inspired me to start this project.
Are tornadoes just mini hurricanes on land?
Hey guys, have we missed anything?
Just showing them my tornado box.
Oh, cool.
Tornadoes and hurricanes are different from each other, but it turns out they're very similar in that they're both low-pressure regions, and they have counterclockwise wind patterns. They also both have tremendous energy.
I'm concerned if the hurricane is going to ruin our fun. How can we predict where it will hit land?
You've asked one of the biggest questions a meteorologist asked. To find an answer to this question, they ask such questions as, where has the hurricane been? Are there high and low pressure systems that affect the hurricane? And what are the speed and directions of the steering winds?
Steering winds?
Yes, those are the winds that push the hurricane along.
That's a lot of variables. Remember, with the scientific process, we have to keep track of all the variables.
We're pretty good at making predictions.
Well, let's see. We have a number of objects. I want you to pick them up one at a time and see if you can tell which ones will float.
That's easy. I think this apple will definitely float. I played bobbing for apples before, and I remember seeing the apples float in the bucket. Yep, I was right.
You used your previous experience to make a prediction. Hurricane forecasters also rely upon their previous experiences. They look upon what previous hurricanes did in similar situations.
Okay, let's try this golf ball. I think it will float. Oops, it sank.
Well, try this bowling ball.
I think you made this one too easy. It will definitely sink because it's too heavy.
All right, let's see.
Wow, two in a row wrong.
I guess you can't tell just if something will sink or float. What are some other ways we can tell if something will sink or float?
You know both the mass and the volume of each object. If the mass of the object expressed in grams is greater than the volume expressed in milliliters, it will sink because it's denser than water. The problem with hurricanes is there are so many variables. It's a very complex problem. And even if we knew all the variables precisely, we're not quite sure how they all fit together.
So what do they do?
Instead of being able to make an exact prediction, all weather forecasters can do is to talk about probabilities.
We need to learn more about probabilities.
Let's look at an example. When we flip this coin, will it come up heads or tails?
We don't know.
That's right, because it's a random event. But what's the likelihood that it'll come up heads?
I guess it'll come up heads about half the time.
That's right. And probability says it'll come up heads about 50% of the time. Let's try it.
I get heads, tails, tails, and another tails. Wait, it didn't come up heads half the time.
Well, that's all right, because probability says we do a lot of trials that'll average out to be 50%. Let's keep trying.
Got a heads, another heads, a tails, and a heads.
Yes, it's looking better. I think I remember the weatherman saying last week that there was a 60% probability of rain. Does that mean it's going to rain 60% of the day?
No, I think that means that if there are 10 similar days, then it would rain on 6 of them.
I think you're catching on. Hurricane forecasters will give the most probable landfall time and location. They also try to predict the strength of the hurricane. The more confident they are, the higher the percentage of the probability.
But can't some of the variables change after they make a prediction?
You bet, that's the problem. For example, if a hurricane steering winds slow down and the hurricane stalls over very warm water, it might not only change the landfall time, but it might also allow the hurricane to gain in strength.
So how do they get the exact measurements?
And how many variables do they have to measure?
Well, hold on now. Weather satellites are a great tool for making predictions and tracking hurricanes. Why don't you talk to Nita Rapp at NASA Langley Research Center? Just got an email from her. She's right now at the Air and Space Center in Hampton, Virginia.
I don't live too far from there. I'll ask my mom to take me.
Hi, Miss Rapp. Thanks for meeting us.
Sure. What's the problem?
We need to learn more about collecting weather data.
Yeah, we're worried about Hurricane Ichabod in the Atlantic Ocean, and we wanted to make sure it doesn't ruin our trip to Florida.
Well, that wouldn't be good. Well, weather data is collected in many ways, but one way is by a weather satellite.
What is a weather satellite?
A weather satellite is a man-made object that's put into orbit around a planet to help gather data all around the globe. It helps improve weather forecasting.
That's just what we need.
How do satellites get into space?
They're launched into orbit by rockets, and sometimes even the shuttle takes them up.
Okay, but how do they stay up there? Why don't they fall back down to Earth?
Satellites are held in orbit by a force called gravity. Here, let's do an experiment. But first I need a ball. Thanks. Now, pretend that you're the Earth and the ball is a satellite and swing it around your head.
This is cool, but satellites don't have strings attached to them, do they?
No, gravity is the string that holds a satellite in orbit. By swinging the ball, you are giving it forward motion, or momentum, just like the rockets do for the satellites. If the string weren't attached to it, it would fly off in one direction.
Oh, I get it. So if we didn't have gravity, the satellites would fly off into space.
Very good. And when the momentum and the gravity are equal, the satellite stays in its orbit.
I saw on the NASA Langley website that they use geostationary satellites. But what does geostationary mean?
Well, if you break the word apart, you have geo, which means Earth, and stationary, which means fixed at a point. So a geostationary satellite orbits at a speed that matches the speed of the Earth's rotation, so it always stays over the same latitude and longitude.
Are there other kinds of satellites?
Yes, there are several types of weather satellites, but the most common besides geostationary are the polar orbiting satellites. These constantly circle the Earth in an almost north-south orbit.
Why are polar orbiting satellites important?
Because they cover the entire globe, unlike geostationary satellites that only see the same portion of the globe all the time.
How many weather satellites are there?
Well, counting only the geostationary and polar orbiting satellites, there are about 18. However, there are about 2,671 satellites of all different types in space.
Wow, that's a lot of satellites. They must be important.
Yes, they are, and especially weather satellites. They help us monitor storm development and track the movement of storms.
Are they just used for hurricanes and tropical storms?
No, they're also used to help our local meteorologists forecast our weather. This helps them issue warnings for thunderstorms and hurricanes.
We can now see that meteorologists have a lot of help collecting data from satellites.
If you want to learn about a really cool satellite that'll be launched in the future, you need to go see Bill Smith.
That sounds like our man. Thanks for your help.
But first, before we go, let's go check out another hurricane room.
Bye, guys.
Bye.